Okay, hi Skillis. Good day all. I'm Nasim, your moderator for today. Thanks for joining us today for machine learning with Python. Okay, we are so delighted to welcome all of you here. And before we start our session for today, please take note with our house rules. Number one, if possible, switch on your video camera throughout the sharing session. And number two, all participants should mute your microphone when not speaking. And number three, leave your question or inquiries into the chat box, and our trainer will do their best. Also, we want to encourage all participants to have active engagement and happy learning throughout the sharing session. Okay, without any further ado, let's welcome our talented trainer and subject matter expert, Dr. Carol, to start the course. And I shall pass the platform to you, Dr. Carol. Have a great session. Enjoy.
Okay, thank you Nasim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Khairul. Today I would like to share with you the course today what we call as a machine learning with Python. So let me share the screen first. Okay, can you see the screen?
Yes.
Okay, good. Okay. So today I'm going to share with you machine learning with Python. Okay. So there are two objectives for the topic. For the first one, I'm going to explain to you a brief method how to install the Python to your system, and then we are going straightforward to develop a machine learning model for uh, the application that we want to develop. Okay, so basically, when we want to develop the machine learning, so there are a few steps that we need to go through. Okay, the first one is you need to import the data that you have. Okay, and then we are going to need to clean the data. After we import and we clean the data, okay, you need to split the data into training and also test. Okay, you need to split the data into training, which means the data portion that you need to send to the model so that the model can learn, right? Can learn based on your data, because when you send the data, you need to tell the model that the label of the data. Okay, and then they learn from that. And then another portion of data that you feed into your system, you are going to test your model that has been trained. Okay, example, you have the 100 sets of data. Okay, 70 of them will be used for training. Okay, and then once the module has been learned, has been trained, and your next stage is you are going to need to test your trained model, either it's work or not, right? So you are going to have to use another 30% of data, right, to test your model. Okay, and then so once you split the data into training set and test set, then you can create a model. Okay, or you can choose the model that you want, which means basically this algorithm machine learning that you want to use in your system. And then once you create a model, then you're going to train the model, right? And then you can proceed with the prediction by testing with the real data. Okay, once you have the result, then you can go to the next stage to evaluate your machine learning accuracy and to improve your training model. Okay, so to improve the training model, can use another set of data, or maybe you can feeding more data, for example, so that the accuracy of your training model will be improved, right? Okay, so basically these are few libraries, the common library that we are going to use in machine learning. Firstly is the NumPy, which is the library for Python. Okay, which is this NumPy is the purpose is to cater on multi-dimensional array. Okay, so if you have the data, okay, you feed your database. Okay, your data that you're going to feed your training model based on data array. Okay, which means you have the row and you have the column of data. Okay, data number one reflect to the next column. Okay, they are correlated each other. Okay, you have all those data. So this basically is the multi-dimensional data array. So to handle that kind of data, you need a NumPy library. Okay, the next library that we are commonly need is the pandas. Okay, the panda, basically the panda is data analysis library. Okay, basically the when you have the multi-dimensional array data, so in order you want to train this data, right, you want to capture the features of the data and then you want to put inside your training model, you need to extract the features, right? You need to extract the feature, the unique features from that row of data. So how to going to do that? So you need the library to handle that. So the library that allow us to process, okay, to process or to extract the data, raw data from multi-dimensional array is the pandas library. Okay, so we need to panda library to analyze your multi-dimensional array data, and then basically the panda is by using data frame concept. Okay, and then we are also will be use the Seaborn. Okay, the library for Python we call for Seaborn. The purpose is for two-dimensional graph plot. Okay, two-dimensional graph plot. Basically, let's say you want to understand the data, right? The correlation between two parameters. So we can visually explain the correlation of the data by using the graph. Okay, so then in order to plot the graph, we need the Seaborn library. And then the next one is the library for machine learning. Okay, scikit-learn. Okay, so once you download the scikit-learn, basically inside the scikit-learn we have a lot of algorithms for machine learning. Okay, a lot of algorithm machine learning. So you can choose what the algorithm that's suitable for your machine learning application. Okay, so basically we have four libraries that we are going to use. The first one is NumPy to cater the multi-dimensional array, and then the Panda is for data analysis library, and then Seaborn to plot the graph, and the library for machine learning algorithm, which is we download from, we utilize from the scikit-learn library. Okay, now, so why we before we proceed with the detail of the example of the program, so I would like to share a bit on why we use the scikit-learn. The first one is the community, okay, the developer of the scikit-learn library, they did a very good job where they provide a very good, incredible documentations. A lot of example, a lot of explanation has been provided by the scikit-learn community. And then we have also a lot of learning algorithms. Okay, a lot of options. Okay, we have the regression, classification, clustering, support vector machine, right? And then the dimensionality reduction and so on. So all this kind of library is very suitable for you to explore. Either you want to do for supervised learning based, unsupervised learning based, or maybe the reinforced learning method. So you have a variety of options to choose the learning algorithm from the scikit-learn. And then of course the third one is the numerical stability. Okay, based on the community feedback, the library, the algorithms from the scikit-learn is very stable, so it can handle a lot of data, thousands of data, like feed into the system, then it can train and predict accurately. And of course the training process is quite fast. And the last one is we have a lot of the users from the users, the scikit-learn user. We have a big community from the scikit-learn users, right? So everybody is always sharing with the thought, the feedback, the comment, the improvement they share in the scikit-learn's community feedback. So we always can refer for each particular algorithm that we are working for, right? So now we are going to download the Anaconda. Okay, Anaconda is a platform. Okay, it's a platform to develop and deploy the Python. Okay, it's a platform to develop the Python, right? So you can go straight forward to anaconda.com and then you can download. Okay, they download the software based on your operating system, either based on Windows or Apple's Linux and so on, right? You can choose the software based on your operating system. Okay, once you download, for example, this one for Windows. Okay, once you download the software, then you go to the software, you double click, and you can start the procedure to install the Python by using the standard method, right? So once you click the install anyway, for example, once I click this one, okay, this window will came out, and then you straightforward go to install anyway, okay, right? And then this window will came out, and then you just go to the next, okay. I agree. You click for up to you which one you want prefer. The next, and you choose your folder that you're looking for, okay, next, okay, and then you install. So now is the installation process, okay. So it will download all the software, all the libraries, all the necessaries in the package that the basis platform need to run the Python, okay. Okay, so when you run, you go to the next and finish. So once it finish, so you go to the command prompt, you can find the Anaconda Navigator, okay. Once you click this one, okay, when you click this one, basically Anaconda Navigator will be appear in your system, right? Okay, so basically you go here, okay. Once this one available, you can go to Anaconda, or we can go straightforward to go to our IDE Python based on Jupyter Notebook, okay. So Jupyter Notebook is the IDE has been downloaded in the in a Anaconda platform, right? So the beauty of Anaconda is once you download the Anaconda, all the IDE library, all the this Jupyter Notebook IDE, Python IDE will be download, okay, in Anaconda. And the good thing is all the library, the basic library, okay, for Python will be downloaded as well. For example, the pandas, for NumPy, okay, Seaborn, right? So the library will be downloaded together with the Anaconda. So that's the good thing with Anaconda, okay. And then you can go here to your Windows search area. You go here, you can type the Jupyter Notebook, and you can click this one, okay. So that is the process how you can download the you open the Jupyter Notebook, okay. Jupyter Notebook is the IDE for Python, okay. Okay, once you open the IDE, so basically we are talking to this one, okay. Let me open, for example, Jupyter, okay, for example, okay. So I just type JUP, and then this one is appear in your system, and just double click. Okay, once you click, okay, this one will be appear, okay, this one, okay. So this is the IDE for Python, Jupyter Notebook, by using the Jupyter Notebook, okay. And then now is show you the, for example here, it show you all the directories in your system. So let's say to be easy, I just want to go to my desktop, right? So I'm desktop, and I just create the folder that I want, okay, in advance for my machine learning Python, for example. So now I create here, for example. So this is the project. So if you want to go to the desktop, okay, and then you want to create the new IDE page, so you just go here, new, and click here, Python 3, okay, Python 3 and PyKernel, okay. Then what happen is when you click this new Python, and the new IDE page will be open for you, okay. So this is the Python IDE that purposely designed for data analytics, okay, and also for the machine learning, right? So this is the Jupyter Notebook IDE by using from Anaconda, right? So the good thing of the Jupyter Notebook is the interface is quite clear and very neat and very clean, okay. It's a very easy and very suitable to display the data and for the training model that related to the multi-dimensional array, okay. So this is where you write down your code, okay. And then this one is all the tab here, okay. This one is to open the new page for your Python, okay. This one is all the edit to copy the cells. This one we call cell, and so on. So once you write the code here, then you can click here run to run your code. Okay, so basically this is the page IDE. Okay, so now let's say I already open this one. Okay, we want to run this program. Okay, this one I built in advance. Okay, so consider this one is your page IDE, right? So let's say this is a common area. Okay, so this one is this how we can do our code. Okay, this one for example I want to testing this page. Okay, and then if you have a familiar with the programming, so basically we use the print function to print our string. Okay, to print our text. So this one for example I said afternoon everyone, welcome to analysis class, and then I print again, my name is Cairo, let's roll in the class. So when I write down this code, so let's me run. So this is the output. Okay, so let's say I change for example everyone. So the tag also will be changed because this is our code, and then once we run, so the output will be displayed underneath. Okay, so this is basically the simple code to print out something, right? Now, so I believe for those who enroll this class, basically you have a background in programming, so we go straight to the machine learning programming. Okay, now this I want to share with you how we can do a simple machine learning project, okay, by using the Python. Okay, for this first activity, basically I want to show you how we can develop the machine learning system that able to predict, okay, the favorite entertainment for the people based on their age and their gender. Okay, so basically I have this data. So basically I have the data basically I download from the Kaggle, right? So this one from the Kaggle, as you can see here. Okay, this data I can go to the Kaggle, and then we can find our necessary data, right? So then we can train ourselves to use the data for our training algorithm, right? So basically I just open this one. Okay, let's see, this one is the music that this file is show the data based on basically this one. Okay, based on the age, the gender, and their favorite entertainment. Okay, this data has been provided, has been collected, has been downloaded from the Kaggle, which is the Kaggle is one of the data website that share with us a lot of data for community, right? So this is basically the data that I just download from the Kaggle. From this data, basically we have the data for age, gender, and type of entertainment. Okay, so one is basically maybe we can define as a male, for example. Okay, and 0 is a female. Okay, it's mean for 20 years old male. Okay, basically based on data, maybe the data based on sharing by some group that do some survey, for example, they share with us. Okay, for those who age 20 male, they like hip hop, for example. 23 they like hip hop, but for those who 20 years old female, which will be represent in 0, the kind of entertainment is they like dancing, they like to dance. So we have this data. So the useful, we have a lot of application we can use to develop based on data up to our creativity. For example, let's say you want to develop one apps. Okay, one apps like kind of for example the Spotify, for example, right? So let's say there's some app that function like Spotify to share with you some of music. Spotify to share with some music, right? You want to do the same concept of app that suggest to you the kind of entertainment. So this system is able to predict to the users what is your favorite entertainment based on their age, and also based on their gender. So this one, if you manage to develop this kind of system, so this kind of apps is very useful to the user, and also the user will be feel very pleased. Why? Because once you open the apps, so they have a lot of suggestion, entertainment by the apps that really suit with them. Okay, why this one is so important? Because we want to develop a very user friendly system, right? A very interesting one. So that may be the kind of the application. So we have this data, and we want to develop that kind of system. Okay, we want to develop the apps that able to suggest the correct the uh, the the favorite entertainment based on the age and gender. Okay, so we have this data. Now we want to develop this data. Okay, we want to develop this data. Right, so that we want to import the data to our Python, so that the Python can be used the data to train the learning algorithm model to predict the entertainment. Okay, so next time when the user, maybe the user download the app, the user fill in the name, fill up their age, fill up their gender. So based on the data input from the user, and then your training model will be referred to their that train database, and try to suit what kind of the entertainment that the system can offer to the new subscriber. That is the idea. Alright, so now let's go to this one. Okay, so the first thing, if you remember, the first step is to import the data. So this is the function to import the data, right? So before we can import data, we need the library first. Okay, we import pandas spd, which means now after this we just simply using the pd acronym, which will represent the pandas. Okay, we import the panda library. Now this one is to import panda library into our page, to our first system here, our program here, right? And then we just pd.read underscore csv, which is the function to read the data set. Okay, to read the data set. Which data set? Data set that we just downloaded, which mean the file name is music.csv. Okay, remember, so this is our data that we download from the Kaggle. The file name is music, so that's why here we want to read this file, we must tell the Python the file name is music and the file type is .csv, right? So that's we want the panda want to read this file, right? So once we read this file, then we can display the data. For example, this one is this command to display what the data that we just read, right? Now, okay, so this one we need to develop this one, right? Okay, right, so this one, okay, so all the information, all data that we read from this music, we put under this variable, right? Then we just go here, we want to display what the data that we just download from the data set, we run here. So this is the data that we just read from this file. So open this file, we have this information, right? We have this column age and all this data, we have this column gender, and we have the gender column. So all this data now is available in Jupyter Notebook. As you can see here, is similar data, right? And this one is just a number for each row, right? So we have the age, gender, and genre, right? Now, so we want to clean the data first, to prepare the data first. So if you remember, the next one, you want to split the data for input and output. Okay, so input and output. So now the input, you need to know which tab is input and which tab is output, right? So imagine we want to train the model. What is our output? Our output is what is we want to develop a system that able to suggest the entertainment. What kind of the genre? Okay, what kind of the entertainment here? So we may have hip hop, jazz, classical music, dance, acoustic, and so on, right? And the way system that able to give this output is based on this input, the age and gender. So we need to split the input and the output. Okay, so now we know the input is age and gender, and the output is the kind of this entertainment, right? So now, so to set the input, we need to clear out the column, this one, okay, this entertainment part. Okay, we need to clear up, we need to remove this one because we just want to define the Python. To tell the Python the input is just age and gender. So this one, as I mentioned before, this one to import the Panda data frame, Panda library. They want to read the our data, and we need to drop this column. Okay, this column. Okay, so now once we drop this one, now this one, the data that has been dropped only now available is age and gender, so will be parked under X variable. That's why we use type X. So this X represent this information. Now this is we input, we put under X variable. Okay, this input we put under X variable. Now we have this input. Okay, the input has been ready. Now we want to set the output. Okay, so this one, the same process. Okay, we just want to this one. Okay, the music data, we choose this tab. Okay, this column. Okay, this column, generate, and then we park under Y. Okay, so when we run this code, so now we have the output. Okay, so we have the output. This output represented by Y. So remember, X as an input, Y as an output. Okay, now the next step is to learn and to predict using the scikit library. So this one we use the decision tree. Okay, from this one sklearn under 3 module, we import decision tree classifier algorithm. Okay, so now we already import the pandas library. Okay, and then now we also import the machine learning algorithm, right? So now this one is just to write again to read the data. Basically we don't need to write again because we already did it before. For the next time I just put it here so that you can see the flow of the program, right? So basically we import the library, we read the data for input to train the model, right? So now we have the input, we have the output, right? X as input, Y as output. Now this one decision tree classifier as a machine learning algorithm, because decision tree classifier it may be too long, maybe to the programmer they don't want to typing so too long, they park under model. Okay, next time when you write down the model, basically is you're calling this algorithm. As you can see here, model here, which means decision tree classifier, you want to fix the X values and Y. Okay, and then you want to predict. Okay, make a prediction model. Okay, you model the predict, and then this one 21 is age and 1 is male. Okay, 22 is age and 0 is male, and then you just make a prediction. Very simple. Okay, as you can see here. Okay, now I want to predict what kind of the entertainment for these people like 21 years old male and 22 years old female. So based on this prediction, basically based on the previous table, the previous data, male 21 years old should like hip hop based on the database. Okay, based on the data feeding that we used before for training. And then the 22 years old all female should like apa? Should like this one, 22 years old, right? Female. Okay, 22 years old female here. And so we don't have the data here, but the system also able to predict based on the input. As you can see here, we have the input for 20, 31, 35, 36, but we don't have the data in between. But the system able to predict the output based on the trend. Okay, as you can see here, 20 years old, 0 is for female. Okay, for example here, 20 years old 0 is female like dance. 21 years old 0 female also like dance. 35 years old 0 female also like dance. So by logic 22 years old should be also like dance, and then your system able to predict that. Okay, that's why when we train, okay, we make a prediction for 20 years old or female is like dance. It means the prediction is tally with the database that we use to train the model. Okay, alright. Hopefully you already understand the flow. Okay, let me repeat again. Okay, maybe you want to a quick one. Okay, basically first we import the data, right? We import the data, and then now we want to split the data if the data has no error. Okay, maybe some row is null, then maybe some error in typing, should be this one a should be number, but suddenly maybe the data you collected they put the wrong data type, maybe they put the name, so you need to clean that. Okay, but in this case the data is clear. Okay, no error, the data is clean. You can straightforward to split the data into train and test, right? So this one no need to clean, so we can prepare to split data straightforward. So we split into two portion, training and test, or input and output. Okay, this one is for input. Okay, this one for input to the system, so that the machine learning algorithm can use this input as a data set for training model, for training data sets, right? And then this output as the target. Okay, the result that should be. Okay, and then we just call the library. Okay, and then we just make a prediction. We call the library, right? And then we just make a prediction. Okay, remember, just model our algorithm, and then the model dot fit, which is the standard syntax to fit the algorithm to our data. And then this one x and y, which is our input and our output. Okay, based on the data that we just played. Okay, then we can make the predictions. Okay, make the prediction, and then the model that predict. Okay, model that we predict. Okay, model, this one basically we calling here our algorithm to predict what we want to predict. Okay, this one is our input, age and gender. Okay, age and gender, then we can have the output. Okay, so describe. So when we execute this one, the prediction will give the result, which is now 21 years old. Okay, 21 years old male like hip hop. Okay, 22 years old female like dance. Okay, so basically this prediction is tally with the data that we used before for training. Okay, now this one is we can use next one. We can to measure the accuracy, right? If we want to measure the accuracy, we need to import under two library. The first one is the skiller model selection. We need to import the library train test split. Okay, and then we also need to import the library metric to show the accuracy of our system. Okay, as you can see here, now we have this one is standard process. Okay, as I mentioned before, we already have the input and output, and then the only part you need to add to measure the accuracy is you need to put here, this is the command, standard command to measure the accuracy. Okay, to measure the accuracy of our learning model. So you need to put x train, okay, x test. Okay, this x must be tally with the variable that we use. If you use different variable, so this one also need to use different variable, but this one is standard underscore train underscore test underscore train underscore test is standard syntax. But the only thing that you may need to change is your variable. So if you choose different variable, then you need to choose to change this one. Maybe this one you write down input, for example. Then this one should be input underscore train, right? This one maybe you change to output. Then this one should be output underscore train output underscore test, right? So why train and test? As do you remember the step procedure? because once we have the data set, we need to split into two. Okay, the 70% by right is for training the model, and another 30% is to test the model. Okay, so that is what it means by train and test. Okay, then we need to use the train underscore test underscore splits and our input, our output, and then the test size 20%, which means for this project is we use the 20% of the data for testing and 80% of the data we use for training the module. Okay, and then we can call our algorithms, okay, our machine learning algorithm, the decision tree classifier, and then we try to fit this model to our input and output, the training data portion pack, the training data portion. Okay, and then we make a prediction. Okay, we make the prediction test. Okay, let's say we have previously we have 100 data, first row until 100 row. Okay, 80% of them, okay, 80% of them we put here. Okay, another 20% we use for, we put here, so that we want to test whether the system able to predict accurately by using the same set of data. Okay, and then we can click here accuracy underscore our test output prediction, right? So we have the test input and we have the test output. Okay, and then we have the score. So if run this one, okay, so basically this one is 1.0, which means 100% accuracy. Again. So why? Because we use 80% of the data for training. So let's say you up here, maybe you want to go for 70, which 70%. Okay, only 30% of the data you use for training. So let's see what happened. As you can see here, the score is less than 0, which means maybe 60% accuracy. Okay, so 50% accuracy. So, and this one you click again, 50 something, 53% accuracy, right? So you can keep try to run and see the prediction, the score. So if you decrease the portion for training, the portion data for training, you basically you will get the less accurate algorithm, less accurate machine learning algorithm, right? So you need to remember that always 70-30 or 80-20 is a typical range that we use data set to train our module. So you may wonder why the numbers has been fluctuated a bit, 50, 53, because if you have the 100 set of data and we want to take, for example, we want to take for 20% of the data for testing, right? So the 20% is basically is random. It does not take the 20% of the above or 30% at the below. It just pick the random, but the total the data they pick is 20%, right? That is the idea. Okay, I'll go to 0.2 again, and you can see the accuracy now 75%. So 100%, 75% again. It's based on the random data they pick. That's why the score has been fluctuated. Okay. Now we want to see persisting model. For example, this kind of situation is when you using this method. Basically, as you can see here, the score is fluctuated, right? So maybe one time your system app is accurate 75% to give the output. Okay, maybe, and then you run again. Another situation, your system able to predict 100% accurate, and then you run again, come back to 75%, right? So the score has been fluctuated. So basically, so in order to avoid that, you need a persisting model, which means you train first and then you measure the accuracy. Only when your accuracy is maybe the highest one, the optimum one, for example in this case 100%, and you want to persist, which means you want to fix, okay, now I want to use this model because during testing it gives me 100% accuracy. Now I want just to log, no more training, I will jump to log the model that has been trained for the system, for the application. Okay, that's what is meant by the persistent model. So what if you want to do that is you need to import the job lead. Okay, this is a method to saving and loading train model. Okay, once you already run, okay, and then you log, the accuracy is as high, is a very optimum. For example, in this case 100%, you log and you want to apply in your system. So you can use this one, then you can this one, the job lead and done model, and then you can use this one and then you can get your system. So that is the idea of the system. Okay, basically this is a process how to develop a simple machine learning model. So what you need to do is just you want to just import the data, okay, and then you split the data to input and output, okay, and then you import your library, okay, right, and then you feed your library to your input and output, and then you can straightforward to predict, right, as simple as that. Only maybe you want to take the extra application, extra programming part level. Okay, maybe you want to know the accuracy of your system, and then maybe you want to fix to have a persistent model. Then you need another library to proceed in your application. Okay, so that is the idea of the first project. Hopefully you understand. Okay, now let's go to the next one. Okay, this program basically is to import, okay, this one basically to train the model to predict the model based on country. Okay, to predict the model based on the country. So we have a lot of country here, right? So this one is the team. Okay, this is data from teams. So this one, this from this data. Okay, this one also download from the web. Okay, I just download. So this data give to you. Let me open this so that you can see the whole data. Okay, so basically this data to show you the team, which means the country. Okay, country Afghanistan, US, France, and so on. Okay, this one is the short form of the country, the year, the number of event that participate in Olympic, the number of athletes enter the Olympic, the age, the height, and individually the weight and so on, and how how many medal that has been won. Okay, how many medal that has been won by them, right? Okay, so this is the data set to show you the number of Olympic medal that has been won by each country that participated in the Olympic competition. Okay, so let me open this one. Okay, we have this one. Okay, as you can see here, so we have the team, and we have the country, we have the year. Okay, how many years, for example, Afghanistan from previous data, they entered the competition from 1964 right until 2016, and this number of events, the number of competition they compete, the athlete that be involved for every year, right? And then you have this one, the number of medal that has been won by each country. So the idea of this machine learning model is to predict the number of medal that will be win by the country based on their previous record. Okay, we want to predict the number of Olympic medal that will be win by the country based on their previous record. Okay, so same as before. So you can create your new page and then you type this one, import panda. You want to import the panda library, okay, and you simplify into PD, and then this one to read the data, okay, from this file name. Okay, and then this one, your read data from this one has been parked under teams variable. So you want to show what the data that has been import from this file in Python. We just write down again this one, and we display to you this data. So basically it will simplify to you. It show you only some sort of some portion of data from the bottom until the last one. Okay, basically the total is 2144 rows. So we have 2000 rows something. Okay, we have 2000 rows and 11 column. Okay, basically you have 2000 data in Python already, but it show you only part of the data, okay, for easy observation. Okay, so this data that we successfully imported from this CSV file. The next one, we only want to use only few data because we have a lot of data. We want just to pick few data that related that we can use to train the model, okay, so that our model, our machine learning can predict the number of medal that will be win by the country based on the previous record. Okay, so this one this one just a library, right? This one just read the data. We import data from this file name, from this file, from this CSV file, and then we want only to display some few of the data, which is the data from this tab, okay, from this column, from team column, from the country column, from the year column, and so on. Because previously we have a lot of data. We have team, country, year, event, athlete, age, height, weight, and so on. So we don't want all of them. We just few of them. We just want the team, country, year, athlete, age, previous medal, okay, and the current medal that they won, right? So we have this one, okay. We just take some of the information, right? So how to see some of the information? We just write down our variable, and then we just write down here the column that we want to display in Python, okay, because we already know for this column, right? So we just pick which column that we want, that, right? So now we have only 7 column instead of the previous one is 11 column, right? Okay, now we want to find the correlation of data with the model. Okay, we want to find the correlation of the data with the model because we do have a lot of parameter. We have the number of athlete, we have the age, okay, which one is the most correlated one with the medal, okay, and then we just type this one, teams dot correlation, okay, and the medals, okay. So this one, the medals, the data from medal will be correlate with each data and give you the percentage, okay. As you can see here, for the year, correlation is minus, which is not good. The athlete is 0.8, okay, 0 for age 0.0, previous previous medal is 0.9, the medal is 1, which means, of course, because you want to correlate medal column with the medal column, of course they are mesh 100%, that's why you get 1.0, 100% mesh, 100% correlated each other. But for this one, for year, athlete, age, previous medal, you can see which one is the most correlated data that you can use to train the model so that you can predict what how many medal that will be win later, right? So of course you will not decide here because it's minus, you don't want that, okay. And you also have the athlete, okay, 0.8 close to 1, quite good. Right, and then you also have this age, okay, age is 0.02, which means a very poor, it's not really not correlate, okay. So you may want to exclude this one from correlation for your data set. And then you have another one is previous medal, 0.9, is quite relevant as well. So you have two relationship that show a very good correlation with your medals database, right? Okay, now I want to see this data, okay. So let's choose this one based on athlete, okay, based on athlete, okay. So basically based on logic, okay, side of the previous medal, the athlete is the play important role for the medal, right? So that's why we choose the athlete. Okay, now we want to see the relationship between the medals and the athlete, okay. We want to see, okay. So one of the way to see the relationship is we can see in plotting graph, okay, plot the graph. So this one we import the Seaborn as seen as, right. Seaborn is the library to plot the graph.
Dr. Carol, I
Oh,
think your slide's not moving, Dr. Carol.
oh my God. Why?
I think maybe you need to reshare again.
Okay, stop again. You see?
Okay, now it's good.
Oh my God. So I have to talk a lot. So since my screen has been freeze, so I will recap a bit. Okay, based on previous one. Okay, this one is to predict the number of medal for each country based on their previous record. So we just collect this data, right? We import this data to the Python, right? So we have a lot of information from this data. So basically this data coming from here, from this Excel, right? So this Excel we just download from here team from the website. So this is from the Excel. So we import this data to our Python. Okay, so now we have a lot of information, right? So now we want to only to see only few of data. Okay, instead of all of this, we only to see just a few of data. How to see only few of data? You put the themes and you just name your column. Which information from which column that you want to see the data, right? So in this case, these are the data that I'm looking for, right? The country, year, athlete, age, and so on, right? So now we have the few data, so which we believe is the most correlated one, but now we want to see which data is very correlated with the medals, right? Because we want to predict the number of medal won by the country, right? So we need to find which parameter is correlated with the medal. So we just find this function teams dot correlation again in our data or medals. Okay, we want to predict the medal. So once we run this one, so it will give you the correlation for each column to the medals. Okay, as you can see here, the year, the correlation is minus 0.02, the athlete 0.8 correlation, which is quite good, the age 0.025, okay, and the previous medal 0.92, also quite good, and then the medal 1.0. Of course, if you match the medal with the medals data row, okay, data column, of course it match perfectly. That's why the correlation is 100%, 1.0. Now we're looking which data that we can use. Okay, so other data that we can use to train the model so that our model can predict the medals. Okay, to predict the medal that has been won by the country. So basically, of course, this one we will exclude. Okay, we'll exclude this one here. We'll exclude this one, right? Because the minus 0.02 is not correlated at all. And then the age, okay, maybe this one for this that it show you the correlation only 0.025, which is not correlated quite good. Okay, not quite good to your medals. The only two that you have is an athlete 0.8 and the previous medal 0.92. So by make sense, so basically you choose the athlete because basically athletes play the important role. Okay, play the main part for your to win the medal. That's why we predict the number of medal that will win by the country by using the athlete. So now you want to see the relationship between these two. Okay, we want to see the relationship between the medals, okay, with the athletes. So we just import the Seaborn. Seaborn is a library to plot the graph, and then we simplify Seaborn library as SNS. So basically that's why SNS is the library Seaborn. Import is to import the graph. So X as athlete, okay, and Y as a medals, and then with the data, this one is team, okay, and we fit with the regression true, and this one is none, which means the confident. We remove the confident interval between the data, which is the default by one. The default setting we just put none. Okay, so once you run this code, so what happen is you can see this one. Okay, the plotting graph, the relationship between athlete and the medals, and also the regression line. As you can see here, it's quite significant, it's quite correlated. As you can see here, the athletes will be affect the number of medal that will be win by the country. Okay, so it makes sense. Of course, if one country, for example France, they send 20 athletes, and another country Zimbabwe only seen one medal, of course the France will be win more medal compared to Zimbabwe, right? It's based on logic. Okay, so that's why if more athlete the country send to the Olympic game, so more medal will be win. For example, it's a simple assumption. As you can see here, now we have this number, right? We have this relationship, and it not really good, but seems quite significant the correlation between these two. Now again, we want to show you, because now we show you the relationship between athlete and the medals. Now we want to show you the relationship between age and medal. Okay, because you know, right, before this we correlate the age is 0.02, right? So now we just want to see the relationship in graph so that you can visualize the relationship between these two parameters. So as you can see here, now we plotting the graph, right? We plotting the graph based on the age and the medal. As you can see here, the data is not really normally distributed. Okay, the pattern, because now the age is 2, the number of athlete basically is from 22 and 30, the most common age that people send for Olympic, and this one is, and the rest is too old, right? So that's why the data is not normally distributed. So it's not a good data set that you can use to train the model. Okay, so this one just to show you the ambivalent data because of missing value, because of course how many countries that can use more than 100 medal. That's why only few one, only very infrequent. So most of the medal will be win only maybe each country. For example, most of the country win more. For example, 10 medal. That's why we have 2,000 frequency, which means most of the country will win the medal around 10 medal, like that. Okay. So that is the purpose of this graph. Okay, now we just want to predict this one. Just skip this one because you don't need. Okay, just drop the. Okay, this one just want to find the missing value, because some of the country have the no data, right? Okay, some data, this one previous one no data, so we don't to use this. So we want to drop or remove that row that has a missing value, because this for in this case this one is not relevant. Okay, it's not really relevant because data is missing, or there's no value. So we just drop this one, then we just have the numbers. Okay, because this one is missing value, which means we don't put a number. So this one kind of the error for data set. So we cannot use this one as part of our data to train the model. So we just only use the data that complete with the information. So now we have drop all these data, all the country that have no information. Okay, so unlike this one, like Afghanistan, Zimbabwe, and so on, we have the information. Even though it's zero, it's still in the information, right? Okay, so this one is we want to use the data recorded. Okay, because we have the data that enter the game from 1960 something to 2000 something. So we want to split the data range. So the data from 2012 and below, as part of the use the data for training, and then the data set that higher after 2012 is will be used as a test, right? So now we want to use this, the train data set. We have 407 rows and the test is 7 rows, right? Okay, so now we use this one. We want to use the linear regression. Okay, we import from this sklearn library and the linear model, and what kind of algorithm, the linear regression algorithm. Okay, and then linear regression algorithm we pump under REG. Okay, then we want to predict, okay, the athletes and previous model to target the model. We want to fit into our algorithm, right? So to make it short, so basically now using the same concept, now we like this one, the music one. As you can see here, now we can predict, okay, predict the number of medal that won by the country. Okay, for example this one is the, for example this one. Okay, we want to predict the number of team by USA. Okay, let's run this one. Okay, USA, the medals, okay, previous medal is 370, okay, and the prediction is 2085, okay. 264 medals, okay, the prediction is 236, which is quite not really 100% accurate, but give you some indicator that the system able to predict the numbers that won by the country. Let's say I want to test the France, for example. So this one, of course, they will show you the latest code line. So you want to test to find to predict how many medal that will be win by France. Okay, so the France is the medal that win 82. Okay, and the prediction is 86. Okay, and then in 2060 the medal is 96, the prediction is 96. Okay, let's try another country, New Zealand, for example. Okay, okay, now we have, for example, New Zealand is the medal win is 27, the prediction is 24. Okay, the medal wins is 31 is 36, the prediction is 35. It's quite accurate. Okay, so it depends on the how the data that we have to train the model and which one data has been more accurate. Okay, let's try this one for Italy. Okay, so Italy is 68, the prediction is 57, the medal win basically in 2060, as the actual one is 72, the prediction is 78. So basically our system able to predict something which is not really 100% accurate, but give you some indicator data that how many medal that has been won by the country for the Olympic Games, okay, for each year, right? So any question from the participant so far? Okay, let's go to the next one. Okay, so this one example is we want to make a machine learning model to predict the car price. Okay, to predict the car price by using this data. Okay, to predict the car price. Okay, so to run this one, the first one we need to import the pandas library. Okay, as I mentioned before, the pandas library is a library to analyze the data set. Okay, welcome Muhammad Daniel. Okay, have you used the Python before, Muhammad Daniel? Okay, so you import the library. Okay, and then we want to read the data. Okay, we want to import the data, and so our data is car dataset, the file name. Okay, so this file must be saved the same folder where you save your Python. Okay, so when you create your Python, okay, good Daniel, don't worry. So you can explore Python with me right now. So if you interest more, you can go further the detail later. Okay, so let's focus this one. Okay, this one basically we want to use the Python, okay, to predict the car price. Okay, so we want to use the machine learning algorithm. So there are few steps, the simple step that you can use. The first one is you need to import the pandas library. So why you want to import this panda library? Because this panda library, we need to use this panda library to analyze the data. Okay, to extract the features from the data. For example, to allow the data to be displayed right here, right, like the data frame here, the panda library can do. Okay, that's why we need to import the panda library. Okay, so when we import the library, now we can use. So we use this one PD because panda SPD we simplify. If you don't put SPD, then you need to write down here pandas full like this one. Okay, so pd.read underscore CSV basically is the function to read the data from file into Python. Okay, basically to import the data from file to the Python. Basically this one from .csv file, okay, under this file name into the Python, and we park the data that has been imported under this one data frame. Okay, df. Up to you. You want to put df. This one just a variable, right? You want to put data, for example, You want to put, even you want to put car underscore data, is up to you. I just simply put DF because it's short and easy to remember. Okay, and then this one is shape. It's just a function in Panda that allow to you to see how many rows and column your data is. So in this case, based on this car underscore data set, we have 205 rows and we have 26 column. Okay, so that's why here you can see here. Okay, if you can open the car underscore data set with SSV here. Okay, let me open here. It may take time to load the file. Okay, car data set. So we have 200 something rows. Alright, 205. Okay, 205 data, and we have how many column? We have 26 column. Right, we have 26 column. Okay, so we have a lot of data for this one. We have the symbol, we have the name of the car, we have the information of the fuel types, we have the information on how many door of the car, what the car body types, the drive wheel, the engine, the wheelbase, and so on. All the car information. Okay, so we want to predict the car price based on this information. So we may need the whole of data at the moment because we just want to simplify first. So we can use only few of data to predict the car because we already know some we can predict the price of the car with some important information, not all the information, because some of the information not relevant to the car price. For example, maybe fuel type, for example, right? So basically, the car price not really determined by the fuel types, either petrol or gasoline. The price is not really significant. Right? So we don't use, for example, we don't use the fuel type as the parameter to train the model. So we go to that later. So at the moment we already read the data and we know the how many rows and how many column. So this one just option. If you want to know, you can use the command. But if you don't know, if you don't want to see this detail, you just skip this command. So this one just to show you what is the column that we have. Okay, how many column, and just to show you the first 5 row information. So this one basically quite important if you have this a lot of data like this, right? So it's very confused to see whole the data in one page. But if you just want to snapshot some of the data so that you can have an idea what this table all about, right? Then you can just write down the command df.head and column here, open and close column, and you can see here the brief information about the tables, okay, about the arrays, about the about the data, right? So basically this data is about have some ID, have some symboling, have some name, fuel types, at least you know in brief what this data all about, right? So then if you want to know detail, you want to describe some of the simple statistical info of your system, then you just use this command, data frame dot describe, right? Data frame dot describe. Okay, basically this one is your data lah, your data here. Okay, your data, you call this data and then you describe some to describe the data, which means when you run this code, it gives you some the brief information, brief statistic information of the data. Basically, how many count, okay? Of course, we have 2050, the mean of the ID, the standard deviation. So this means basically all these basic statistic for each column, okay? So basically for engine size, right? So the minimum is 61, right? The maximum is 326, for example. Okay, the car height, the maximum of the car height, for example, is 59. Okay, and the minimum is 47. Okay, and you can also go this one. So the stroke, for example, what is the maximum, what is the minimum? So can you have some brief statistic information so that you can know what is your range of your data, if you want to know about that. Okay, and this one just want to check the data type in the data frame. Okay, if you want to check the data type, you just simply put the .info. Okay, your data frame .info. So once you run this code, it gives you some of the data type in your system. As you can see here, the ID is integer, right? Why integer? Because this one just a number, right? ID 1 2 3 4 5 is a number, that's why integer. Okay, and then symboling. Okay, this one 64 is 64 bits. Okay, based on your operating system bits. Okay, that's why they put in 64 here. Okay, and then you have the sum name, this is object. Engine location is a float. Sorry, the wheelbase float. Okay, you can check here, for example, wheelbase float, but because we have decimal point here, right? 205 point something, so point something is a float, and so on. So you can basically, you have some brief info what is the data type for each object. Okay, let me check. Okay, no question. Now this one, you also can check the unique data for each data, right? So you can go here, df.nUnique, you have see the unique information for this data. Okay, enough of that. So we can straightforward to go to prepare the data for linear regression model. We want to prepare the data for training. So now we want to create a new simple data frame using the existing one. So basically we have a lot of data, right? So we have a lot of data. We have the symboling, name, field type, expression. So for the simple one, we want to check what can we predict the car price based on the engine size. Okay, basically that is the most common parameter we look at to the car when we want to predict the car price. Okay, so of course different engine size, there will be, you will give you different price, different car price, right? So you want to use the engine size and the price. That's why you want to use the engine size or price. So basically you can use also the correlation as before, as I show you in the medal, right? We have the medal where we can simply show you what is the correlation between each data frame with the medal. Okay, the same one here, you can simply pick the parameters, find the correlation between each parameter with the price, and then you can pick the higher one. Okay, but this one we just skip this one. Okay, we straightforward to choose the engine size. Okay, so now we just put here, we want just these two column, engine size and price. So now we have this information. Okay, now we want to create this one as a new data. Okay, new data set. That's why you put here new underscore df. Okay, this one just a variable, you can use your own name, but this one is a feed df, the column bracket. Okay, the bracket column, and then your data frame, which column that you want to put as a new data frame. So now we have this new data frame, we have the information on engine size and price. Okay, and this one it gives you the information of row and column. Okay, 205 row and 2 column, because engine size 1 column and price 1 column. Now we just want to see again the relationship. Okay, relationship of these two between the engine size and the price. Okay, based on the data. So we just put here new data frame, we just straightforward plot. Okay, x as engine size, y as price, and the plotting style is scatter. Okay, as you can see here, this is the relationship between this engine size and price. Okay, so what do you think about this scatter data relationship? Is it significant? Is it give you some the linear description or relationship between the engine size and price? So if I see this kind of data, basically you can see some pattern, right, from left to the right. So basically if the engine size is higher, the price is also higher, right? If the engine size is low, the price is also low, right? So you can see this kind of relationship. let's see, we want to see the relationship between the fuel types and price. Okay, as I mentioned before, of course, the fuel type is not really significant to affect the car price. Now we just want to see the relationship. As you can see here, the gas and diesel, the data look like this. So it's not, you cannot use this kind of data to predict something. So it's not really significant because it's not important parameter that determine the car price. So the important parameter that determine the car price is the engine size. Okay, one of the example, one of the parameter, the most significant one. Okay, so by this, based on this relationship alone, we know that the fuel type is not significant parameter that affect the car price, but the significant parameter or significant data that will affect the car price is the engine size. So because of that, we use the engine size and the price as our data for training machine learning algorithm. So now X is the engine size, which is the input, right? And Y as a price as output. Okay, so now we just decide that as input, Y is output. Okay, so now we import this library. Okay, we import this library. Okay, we train, test, split. We import this library, the training algorithm, the machine learning algorithm from linear model. We import this linear regression algorithm. Okay, and we also import this metric to evaluate our machine learning algorithm accuracy. Okay, right? Now this one, we want to split the data as string and ten and so on, as I mentioned before. So we just straightforward, just to simplify the program. Okay, so as you can see here, we just simply here, right? Okay, so we will just want to predict, we just successfully predict what is the price for engine size. Okay, let's say I predict, we want to predict the range, right? From 70, for example, from 70 to, let's see the data first. Okay, let's say I want to predict what is the engine size, what is the price for engine size 200 to 250, for example. As you can see here, the average price should be around here, right? 30 to 35,000, for example. So we will just want to predict this engine size price. Okay, 200 to 250. Let's say 200, 250. Okay, so basically the price is 31,000 something. Okay, so you can see here, this one, if I can draw the graph line here, so basically the price is around here, 30,000 to 35,000 based on this graph. Okay, so our system can predict, okay, based on this engine size from this range to this range, right? The price is 31,000. Okay, so our system able to predict the car price based on the engine size. Let's say we just want to predict the specific car size engine. So let's say we just want to find 300. So based on this graph, the price should be 300, around 40,000 something. Okay, so we just simply change this graph, 300. Okay, so the car is here, 45,000 something, right? 300, okay, around here. So our system able to predict the car price based on engine size as shown in the data training from our data set that we use as a benchmark. Okay, so basically I've shown you 3 examples how we can use the Python to develop the machine learning algorithm to predict based on the data set, based on linear data set, based on the data set from our file that we just download from the internet. Okay, so any question from the participant, Muhammad Daniel? Okay, so I would like to recap my training today. So basically, when you want to do the machine learning algorithm, the first one, you need to import the data. Okay, Daniel, thank you. So you can import the data. Once you import, if the data have some problem, maybe you have some column missing value, or maybe some column have the wrong data type, then you need to clean first. Once you clean, you need to split the data into two parts. Okay, the training part and the test part. Okay, the training portion about 70 to 80%, and then of course the test portion about 30 to 20% of the data you use for testing. And then you want to create a model, you just calling the model, okay, the learning algorithm, the machine learning algorithm that you prefer, okay, and then you train the model, okay, based on the data set that you, from here, right, and then you can start make the prediction, and then you can start after that you have the result, and then you can proceed, you want to evaluate the accuracy, and if you want to improve further, you can, maybe you can use more data in your training module, or maybe new data and so on. So that is the idea for machine learning model, right? So when we have this, we have explored use this library. Okay, so let me recap one example for you before I end this training. Let me go to this example, for this music example, because this one is the most simple one. Okay, so basically, Daniel, this one is to create the machine learning model to predict what kind of entertainment that people like based on their age and gender. Okay, so we have this data set. Okay, we have this data set. Okay, from websites we download, and we want to create the system that able to predict the entertainment based on their age and gender. So as you can see here, we have the age and we have the gender column, right? For example, this one represent a male, 0 represent as a female, right? For example, 20 years old male like hip hop, okay? 23 years old one male like hip hop and so on, and this one female, 20 years old female, okay, like dance and so on. So we have this data set. So we want to predict, we want to create a system. Okay, let's say you want to develop an apps like Spotify, right? So when you subscribe Spotify, you need to register, right? And then it suggests to you the kind of music that you like. Okay, so let's say you want to do the same kind of system. So maybe the new subscriber coming to download, to install your software, your apps. So the subscriber will fill up their age and gender. So you want to create a system that's smart, that able to suggest the correct entertainment that subscriber prefer based on the age and gender. So we have the database. So we can use the database to develop a smart system, a smart app system that able to predict the type of entertainment that people like based on their own gender and age. Okay, so we import the data, right? We import the library Panda, we read this data for music. Okay, we import the data, this data into Python, right? And then we want to split, right, from input and output, because we want to train our model. So obviously age and gender as the input, because we want to predict the entertainment here. So therefore age and gender become input, this entertainment become output. So this one is to make the input X. Okay, so we need to drop this column, gender column, this entertainment column. Okay, so that's why we drop. So now we only have these two table, age and gender as the input, and then this one Y, okay, this column, okay, as the output. Okay, now we already have the input and output, right? So we use this one to train our model. So to train our model, to train the machine learning programming, we need to import the machine learning algorithm. So we import from sklearn library 3 module. For this one, we use the decision tree classifier algorithm. Okay, so once we have this one algorithm, then we can this algorithm we simplify part of the model, because this one is too long. We just use the model, is more simple. So this algorithm basically fit to the input, to the output. So remember, our input X, age and gender, and Y is the output is for entertainment. So we feed this model, this algorithm to our input and output, and then we just make a prediction. So model dot predict is the syntax to make a prediction to our input. So we have this one input age and one is a male. So input age 22 years old and female. Okay. By right, based on previous data, if 21 years old will be like hip hop. Okay. Male. Okay. Male 21 years old should like hip hop. 22 years old female should like the dance. Can you see here the data? Right. You can scroll up this one. Okay. 21 years old male should like hip hop. Okay. 22 should be in between here. We have 20, 21, right? So 22 should be like dance. Okay. Female. So we predict this one. Right. So we predict this one. 21 years old male, 22 years old female, what they would like. So our system able to predict male, this one 21 years old, for this one is hip hop, and 22 years old female like dance, which means the data, the prediction is tally with our data. So now we are already successful to develop a simple machine learning system using decision tree classifier algorithm to predict what kind of entertainment that is suitable for based on their age and gender. Okay, so that's all for today. Any question from the participant, Muhammad Daniel, if you have any? So if you don't have any, I think that's all for today. So thank you. Assalamualaikum. Over to you, Mr. Nasim. Okay, Daniel. Muhammad Nasim, moderator.
So, Dr. Carol, I believe that you finished your course today, right?
Yeah.
Okay, so Dr. Carol, thank you for the insightful and informative session. Okay, before we end our session today, can we take a group photo, everyone? Really appreciate if you guys can switch on the video camera. Okay, thank you. 1, 2, and 3. Alright, okay. Okay, thank you everyone. If you wish to join the classes by Dr. Carol, you can always follow us on www.sketcher.com, and those want to know the upcoming topic from Dr. Carol or other channel, do sign up with our Sketcher platform for more learning by scanning the QR code that I shared earlier in the chat box. And also don't forget to give a rating for the training evaluation today at the Sketcher website. Okay, that's all from me, and once again, thank you, Dr. Carol.
Okay, thank
Okay,
you.
thank you, Daniel. Join the session. Alright. Okay, good night.
Okay,
Bye-bye.
Assalamualaikum.
Waalaikumsalam.